All right, we're going to go over section 4.5. We dealt with functions already. Okay, so we have two functions here, and all 4.5 is dealing with is how can we put two functions together? How do we do composite functions, things like that. Okay, and what that means is really I could plug in a number here and get an answer. I could plug in a number here and get an answer. But what if I added these two equations together, or subtracted them, or did something like that? Okay, so let's f of 2. Okay, would I use g at all for f of 2? No. Okay, so I'd only use f, and all I'm doing is plugging 2 in for x. Okay, so I replace 2 with x, so it's 2 squared plus 11. It should be 4 plus 11, which is 15. Okay, so that's your answer. Same thing if they go g of 2, all I'm doing is plugging 2 in for x. 2 plus 6 is 8. All right. Okay, so really that's not too difficult. Now, where people start to get screwed up is when they go f plus g of x. Okay, and all that means is I'm taking this and then I'm adding this. Okay, so I'm taking x squared plus 11 and then I'm going to add x plus 6. Okay, and so you just simplify and it's x squared plus x plus 11 plus 6 is 17. And that's it. Okay. The next one is f minus g. Oh, whoops. Let's try that again. Minus g of x. Again, you take this function and you minus off this one. Okay, now I'm going to put parentheses around that because what a lot of people screw up is they forget to distribute the minus sign. Okay, so I'm going to have to distribute it to both. Okay, so this would be x squared plus 11 minus x minus 6. Now simplify. So that'd be x squared minus x plus 5. Okay. The next one, you're multiplying. F times g. Put that wrong again. Times g of x. Okay, so really you're just multiplying these two things out. Okay, so it's x squared plus 11 times x plus 6. And you just FOIL it out. So x squared times x squared times 6, so that'd be x cubed, x squared times x. X squared times 6 would be 6x squared. And then to the 11, that'd be plus 11x. 11 times 6 is 66. That's it. The divided by 1 is probably my favorite. Because all you have to do is take the x squared plus 11, which is on top, and divide by x plus 6. That's it. No math. Okay. So then they're going to plug in numbers. Okay. So what they really want you to do is solve all these out like this, and then plug in the number. Okay, which you could do that. Okay. So if they did f plus g of 2, you would just take this f plus g and then plug 2 in. Okay. But there's a lot of mistakes that could be made in this. Okay. Whereas I think if I'm doing f plus g of 2, what I would do is I do f of 2 and I just add g of 2. Okay. This is the same thing. So plus, and then I just plug 2 in for both of them. So then I could find f of 2, which you plug in 2, and that's 15. And then g of 2, which I have right here, which is 8. And then I just add those two numbers together. So you plug it in this one, you plug it in this one, then you, whatever operation they have here, you just do whatever that is. Okay, so if they go f minus g of 2, again, you plug 2 in here, which is 15. So that'd be f of 2 minus g of 2. And this is really easy to plug in. So that's 15 minus 8, 7. Instead of doing all the math where it gets to this, okay, where you come up with something like this and then having to plug it in, you're going to have to plug it in anyways. Just plug them in first, and then you get your answers pretty easy. The next one, f times g of 2. Same thing. I know f of 2, I know g of 2, and I just multiply them. So that's 15 times 8. 15 times 8 would be 120. And then the last one is f divided by g of 2. And so that'd be 15 over 8. And you're done. Okay. Now, okay, so all those have operations in it. So what I would do, again, if they ever gave me one where it's an operation plus, times, minus, divide, just plug in the number and then do whatever math you have to do. Now the next one is a composite function. Okay, so there's a difference. So it's f of g. So there's that little circle involved. That's not a multiply. Okay, that means I'm going to take g and I'm going to plug it into f. Okay, so this can be rewritten like that. Okay, whereas g of f of x is written like this. Okay, so the f goes into the g. Okay, so how that's done. Okay, so f of g of x, that means I take g of x, x plus 6, and I plug it in for the x here. Okay, so this is going to be x plus 6 squared plus 11, and that's your answer. Okay, so you see how I just took this and plugged it in for the x there. This one, I'm going to take the f and plug it in for that one. Okay, so this would be, so instead of the x, I'm going to put x squared plus 11 plus 6. So see how this was the x. Okay, and then simplify that, x squared plus 17. You could simplify this too, and then, but I don't know if they ask you to or not. Domain. Remember, domain and range, well, domain especially, if there's no fractions or there's no square roots, your domain will always be negative infinity to infinity. As long as there's no square roots or fractions. Okay, so these two both, no fractions, no square roots, negative infinity to infinity. Okay, all right, last one, f of g of 2. So this one, except f of g of 2. Okay, so you work this out like this, and then you just plug the 2 in. So this would be 2 plus 6 squared plus 11. 2 plus 6 is 8. 8 squared is 64. Plus 11, 75. This one, g of f of 2. Again, work out g of f, and then plug in 2. So this would be 2 squared plus 17. So that'd be 4 plus 17, which is 21. Okay. All right. Okay, so let's get into some that have actual fractions in it. All right, so the first one, f of g of x. Now, they'll always give you two functions, so f of x is equal to 1 over x, and g of x is equal to x minus 1 over 3. Okay, notice this has a fraction, but nothing can be in the bottom, or you can put anything you want because there's no x in the bottom. So this domain would be negative infinity to infinity. This one you can't have 0 because you can't have 0 in the bottom. So x cannot equal 0. So the domain on this one would be negative infinity to 0 and then 0 to infinity. Okay, but so the first one they said f of g of x. Okay, so rewrite that as f of g of x. So notice I'm plugging the g in for the f. So the g in for the x over here. Okay, so this would equal 1 over all of this. X minus 1 over 3. Again, when you divide by a fraction, you flip and multiply. Okay, so that'd be 1 over 1 times 3 over x minus 1. See how I flipped this? 3 over x minus 1. And then this was 1 over whatever. Okay, so this would be 3 over x minus 1. Then it's going to ask for the domain. What can't go in the bottom? Well, x cannot be 1. So my domain is going to be And then if we map that out, say there's 1, it can't be that, but it can be everything else. So it can be negative infinity, it can be infinity, so it can be anything here, anything here. Okay, so it'd be negative infinity to 1 and 1 to infinity. Okay. The next one is g of f of x. Okay, so rewrite that as g of f of x. So notice the f goes into the g, so this now goes over there. Okay, so that would equal 1 over x minus 1 over 3. Okay, now how can we simplify that? Well, since both of them are divided by 3, this would be 1 over x over 3 and minus 1 over 3. So that would be the simplification. And dividing by a simple number would be the same thing as saying 1 over 3x minus 1/3. Okay, so this is g of f of x. And now notice x cannot be what? So you can't have 0 on the bottom, so x cannot be 0. Okay, so again, number line, there's 0, can't be that, but it can be everything else. So negative infinity to infinity. Okay, so my domain is going to be negative infinity to 0 and 0 to infinity. Okay. All right. Next example. F of x is equal to the cube root of x, and g of x is equal to negative 3x. They're going to add them. So f plus g of x. Okay. Notice there's not a circle here. So I'm not plugging one in for the other. All I'm doing is adding these two things together. Okay. So that's going to equal the cube root of x plus negative 3x, which simplifies down to the cube root of x minus 3x. Domain. Notice it's not a square root, so I can plug anything here I want. I can plug anything here I want. So the domain is going to be negative infinity to infinity. Again, if this was a square root, it would have to be positive numbers, but it's not. It's cube root. And the graph of cube root looks like this. Okay, so I can put any x value in that I want. Okay. All right, the other one says minus, so all I'm doing is plugging a minus sign. So f minus g of x would be the cube root of x minus negative 3x, which makes it a plus. Again, cube root, doesn't matter. So it's negative infinity to infinity would be your domain. The next one I'm multiplying. F times g of x. This times this. The only really simplified you could do is move out the negative. So it'd be negative cube root of x. Let's see. I could move out the 3 too. Okay, so it'd be negative 3x times cube root of x. That's probably how they'd want it. Domain. Again, no fractions, no square roots, negative infinity to infinity. And then divided by, here's where you're going to have a fraction. Okay, so it's f divided by g of x, which is going to equal the cube root of x divided by negative 3x. And you can't have 0 or on the bottom, so x cannot be 0. And so your answer is going to be, your domain is going to be negative infinity to 0, 0 to infinity. Okay. All right, final example. They want f of g of 2 for the following. F of negative 2 is equal to negative 5. And g of 2 is negative 2. This is one of the most confusing ones that we have. But if we write it out, we should be okay. F of g of 2. That's how we rewrite this. Okay. Now, can we simplify stuff? G of 2. Do we know what G of 2 is? Well, it tells you. G of 2 is equal to negative 2. So I'm going to rewrite G of 2 with negative 2. See how G of 2 is negative 2? And then do I know what F of negative 2 is? Well, it tells me that here. So my answer, after all those, is negative 5. Okay, that would be section 4.5. Let me know if you have any questions.